Namaste student, this is Sanjay Nath. Today's session is on the Geographic Grid System, Chapter 2, Latitude and Longitude, Part 1, Standard 9 ICSE. In this chapter, we learn about many fact files about latitude and longitude. What we'll able to learn from this chapter, we'll know about globe and the grid system, we'll know about latitude and angular distance, we'll learn about characteristics features of latitude and how it is helpful to understand or demarcate heat zone of the earth. What are longitudes? We'll also learn what are the application of latitude and longitude. We'll also understand the relationship between the longitude time zone and time, what is international date line called IDL, and what are grid circles. First understand globe and a flat map. As you can see on the screen, there's a globe. You might have seen from the childhood or from school when you were in first, second, third standard. Globe is the exact replica of the earth and it best describes the earth. Globe does have details but is less than that of flat map. A flat map can be used to locate the exact position on Earth's surface, whereas on globe it is difficult to see all the places at once. Flat maps are two-dimensional, pictorial representation of reality or Earth on a flat piece of paper, and always they are drawn to scale. First we'll understand the geographic grid system. In order to know the location and direction of any place on the Earth's surface, there are certain technique has been developed are as follows. These are called the reference point. These reference points are used to measure the location and direction on Earth. First one, the axis of the Earth. As you can see, this is the axis of the Earth, 23 degree 30 minutes tilted on its axis. The North Pole here, the South Pole on this side, and the equator. These four important references have been used to locate places on Earth. This is a very pictorial representation of Earth from different perspectives. As you can see, northern and southern hemisphere has been shown. If you cut the globe from the middle, keeping in mind the equator, the earth would have looked like this. This is the perspective from northern hemisphere zenithal position. And this is the perspective of southern hemisphere from the top view or zenithal position. This is another view of earth, eastern and western hemisphere. As you can see in this perspective, earth or the globe has been cut from the middle, keeping in mind 0 degree prime meridian. As you can see, eastern hemisphere and western hemisphere. If we keep the eastern hemisphere like this, we can see one side of the earth, eastern side of prime meridian. If we keep the half part or the sphere like this, we'll able to see the western hemisphere. Now we'll understand what are parallels and meridians. All the latitudes are also called parallels. As you can see in this sketch, the latitudes are drawn north of 0 degree equator and south of 0 degree equator. All latitudes are parallel to the equator. It measures towards the north direction in degrees, minutes and seconds. It also measures towards the south direction in degrees, minutes and seconds. The equator is 0 degree latitude as you can see here, and the pole are 90 degree north and 90 degree south. Now we'll learn about longitudes. Longitudes are also called meridians and they've been drawn from pole to pole, mainly connecting pole to pole, north pole to south pole. It measures east and west of 0 degree prime meridian. After latitude and longitude, we'll understand what happens if you superimpose both these imaginary lines. As you can see in this third sketch, the network of grid system. Horizontal concentric lines are drawn on this globe are latitudes, and these vertical lines are drawn from north to south pole are longitudes. And they are crossing each other and forming a perpendicular pattern at these vertices. And this is called the grid system around the earth. The parallels and the meridians continued, we'll understand with the help of a video clip. As you can see, a globe is being covered with network of grid. This grid system is latitude and longitude. Latitudes are drawn either towards north of equator or towards south of equator. Longitudes are drawn connecting north pole to south pole and they are vertical lines. Near the equator, they are far, and towards the pole, they are closer. Now we'll understand latitudes in detail. In this picture, you can see latitudes are drawn towards north of equator and south of equator. From 0 degree equator towards north pole, the latitudes are drawn with 15 degree interval. 0 to 15 degree north, 30 degree north. In this manner has been drawn towards north pole. It is increasing towards north direction, northern hemisphere. As you can see in southern hemisphere, latitudes are drawn in certain intervals south of equator, 0 degree to 15 degrees south, 15 to 30 degrees south. In this manner, the latitudinal distance increased towards south pole. Now we'll learn how latitudes and angular distance are connected and how latitudes can help to find angular distance. As you can see, there are two sketches. First one is showing the cross-section view of the earth. Here you can see equator has been marked and is been shown with the help of radius. So from 0 degree equator, if we measure northern hemisphere 90-degree angle, at the apex it will form a 90-degree angle and north pole will demarcate as 90-degree north. Now if you measure from 0 degree equator, this will represent 30-degree latitude and the angle. Another example, if we measure from 0 degree equator 60-degree latitude, this will represent the 60-degree latitude. As you can see, I am marking with the red color. As you can see in the second sketch, from the 0 degree equator, it has been measured 30-degree angle or the latitude. The angle between the radius and the equator equals to 30 degree, and the angle measured between 0 degree equator to the north pole is a 90 degree. Now we'll watch a video clip to understand how latitudes and angular distance have been measured. Latitude and longitude, a 3D view of Earth. If we cut open an Earth from the center, as you can see in the animation, it has been cut on the axis. One can measure the latitudinal angle towards north and south of equator, as you can see, 30 degree north and south, 45 degree north and south, 60 degree north and south, 75 degree north and south, and 90 degree north and south. This represents the angular distance between latitude. Now we'll see, if we cut open the earth on equator, one can measure the longitude as angular distance. From the apex of the earth or the center, keeping in mind the prime meridian, one can measure the angular distance toward east of prime meridian and west of prime meridian. As you can see, 60 degree east, 60 degree west. In this manner, we calculate the angular distance between longitude. This is the result, the grid system. Now we learn how to measure angular distance in a very simpler manner. As you can see on the globe, one protector has been superimposed. I want to measure the angular distance of the red point. For example, this red point is representing the location of Mount Everest. At what angular distance the Mount Everest might have located? If we consider the apex of the center of the earth on equator is 0 degree and we measure towards northern hemisphere, the latitudinal distance or the angular distance would be 45 degree. As you can see, it is shown in the picture. This is the easiest and the simple way of understanding of angular distance and latitude. Among all the latitudes, some of the important parallels that we'll learn: 7 latitudes with a great significance: equator, North Pole, South Pole, Tropic of Cancer, Tropic of Capricorn, Arctic Circle, Antarctic Circle. As you can see in this diagram, as such this diagram is very important. This diagram is representing all the heat zone. All these heat zone have been demarcated with one important latitude. As you can see, equator is a torrid zone. It is between Tropic of Cancer and Capricorn. Tropic of Cancer is 23 degree 30 minutes north. Tropic of Capricorn 23 degree 30 minutes south. So this zone is also called the ITCZ. Now from 23 degree 30 minutes north, Tropic of Cancer, upwards 66 degree 30 minutes north, this area or zone is temperate zone. Same in the southern hemisphere, between 23 degree 30 minutes south and 66 degree 30 minutes south is the temperate zone below Tropic of Capricorn. And northern hemisphere and southern hemisphere, above 66 degree 30 minutes north and south, this area or the zone is called the frigid zone, where sunlight reaches slant at the tip of the south pole and the tip of the north pole. Now we'll understand the 7 latitudes and their significance with the help of a video clip. This is an exact replica of an Earth showing those 3 zones: yellow, torrid zone; light pink, temperate zone; blue, frigid zone. This zone are between this special latitudes. Now we'll see some characteristic features of parallels. All parallels are circle except 90 degree north and south. As you can see, All the latitudes they merge at North Pole or at the South Pole, and these latitudes are drawn in concentric manner, and they are all equidistant. The distance between each latitude is equal. 1 degree difference between latitude 111 kilometers. Now we learned some facts about the lines of latitude. They are also known as parallels because they are parallel to each other or equidistant. Latitudes are run east to west direction. It measures the distance north or south of equator or from equator. All parallels, they never cut or intersect. It crosses the prime meridian at right angle. It lies in the plane that crosses the earth axis at right angle. It gets shorter towards the pole, and on the equator it is the longest great circle. Now we'll learn about the longitude in detail. This one is a sketch of longitude. As you can see, east of prime meridian, longitudes are drawn, and west of prime meridian, longitudes are drawn. Both the side or both the hemisphere, 60-degree longitude is drawn. As you can see on this side, 60-degree, and on the other side also 60-degree. What is the difference here? This 60-degree longitude is east of prime meridian, and this 60-degree longitude is the west of prime meridian. We identify the longitude though they are of same value, keeping in mind they are on the western hemisphere or the eastern hemisphere of prime meridian. Now we'll watch a video to understand. Longitudes are drawn connecting North Pole to South Pole, as you can see in this video clip. All the longitudes, they'll connect at the North Pole and the South Pole. Longitude. Some points to remember. As you can see the sketch, there are vertical lines drawn connecting North Pole to South Pole. These are called meridians or longitudes. Prime meridian marked as 0-degree longitude connecting North to South Pole, and the full circle is 360 degree. There are 180 degree towards the eastern side of the prime meridian, and there are 180 degree towards the western side of the prime meridian. 180 degree east and 180 degree west is the same line and the total of 360 degree. Now what is great circle? As you can see on the sketch, 30-degree west longitude meets at the North Pole and it continues further 150 degree east. This makes a great circle. Distance between two meridians or the longitude on equator is 111 kilometers. These are some of the very important points that you should remember. Now we'll understand the concept of longitude and prime meridian. The prime meridian 0-degree and 180 degree line splits the earth into western hemisphere and eastern hemisphere. As you can see in the sketch diagram, this dashed red line represents the 0-degree prime meridian, and eastern part of this prime meridian represents the eastern hemisphere, and western part of the prime meridian represents the western hemisphere. Places located east of prime meridian have an east longitude address east in degrees, minutes and seconds, and places located west of prime meridian have the west longitude address in degrees, minutes and seconds. Now we'll watch a video clip on the concept of longitude and prime meridian. As you can see, there is a globe showing the network of latitude and longitude. At the middle, this thick yellow color line represents the prime meridian. As you can see, the same line continue from the North Pole and further. The red line represents the prime meridian, and these blue lines drawn on the either side are the longitudes. Western hemisphere, eastern hemisphere. These are called western longitude and these are called the eastern longitudes. Now we'll understand the idea of Greenwich Mean Time. It is also called GMT. Greenwich is a place in England and it is a logical starting point for the time zone. As you can see in this picture, from North Pole to South Pole, 0-degree prime meridian is connected and is passing over the place in UK, England, named Greenwich. From this place, the name has been derived, named Greenwich Mean Time or GMT. The world rotates from west to east direction, counterclockwise, and the time zone to the east of prime meridian is always ahead of the time zone on the western hemisphere. East increases, the time is forward to all the places toward the eastern hemisphere, and west is less and time is backward to all the places towards the west. Now we'll understand what are time zones and why we have different times. Because when the sun is high in the sky in one part of the world, it is night time in another place. Based on the International Prime Meridian Conference held in 1884 in Washington DC, they agreed to divide the world into 24 standard time zones, range of 15 degree longitude. The prime meridian extending from 7 degree 30 minutes west to 7 degree 30 minutes east longitude. Now we'll watch a video clip to understand why there are different times and the concept or idea of time zone. This is the world time zone, 24 time zones. This is a Greenwich clock. Countries represented at the Meridian Conference 1884. They have decided on the 0 degree prime meridian supposed to pass over Greenwich. This is the line that passes over the Greenwich. We'll see some of the very interesting fact about China. China though have 5 different time zones, but they follow only one time zone. Now the globe has been divided into 24 hours, 15 degree interval equals to 360 degree. As per the convection, 15 degree represent one time zone. And on the either side you can see it is further divided into two parts, 7 degree 30 minutes and 7 degree 30 minutes. In this manner the time zone has been demarcated. Thank you for watching the presentation.